In a standard deck of 52 cards, 5 are dealt to form a poker hand. Part A, how many 5-card hands are there? So we have distinct objects, and that's implied from it being a standard deck. No card repeats in a standard deck. And the order in which you arrange them does not matter. So we have ourselves a combination. So in part A, how many cards do we have to choose from? 52. Out of those 52, that's an eraser, not a marker. Out of those 52, how many are we choosing? 5. Now, if you've ever played poker, you should already know this is a humongous number. I think it's 2,598,960. Now, part B spices it up. How many ways can you get all hearts? So when you have all of one type of suit, it's called a flush. But the question is, you only want hearts. How many hearts are there in a deck? Out of how many cards are you going to have in your hand? 5. So it's a combination of 13, 5. What is 13, 5 as a combination? 1,287? Okay. 2 comments. Number 1. In 8.3, it's going to be Chapter 7 combined with 8.1 and 8.2. So a question in 8.3 would now say, what's the probability you have all hearts? So you would take the 1287 and divide it by the 2.5 million. And that would be the probability you have all hearts. Okay? Because then it comes back to the part over whole. That's comment number 1. Comment number 2. What if I had said, how many ways can you get all the same suit? And did not say specifically hearts. Multiply by 4. Where did 4 come from? Yeah, 4 suits. Very good. But we're only zooming in on 1 suit. So if I said hearts, clubs, diamonds, or spades, it does not matter here. You would still have 1287. Okay? Part C. How many cards have, that shouldn't say cards. How many hands have exactly 2 clubs? I have to make this one evil. There we go. Sense. Alright, that's appropriate. Drip right there. This one's evil. How many hands have exactly 2 clubs? What do you think? Can anyone reread part C to have the word and in there? So restate it so the word and is there. Yeah, 3 non-clubs, that's it. So this says how many hands have 2 clubs and 3 non-clubs? Well, how many clubs are there? And how many do we need? And how many cards aren't clubs? 39. Because if there's 52 cards total, 13 are clubs, 39 are not clubs. And how many of those do we need? 3. So the first combination is getting 2 clubs. The second combination is getting 3 cards that are not clubs. Where are we at? 712,042. Did anyone else get that? 7, 12, 8, 4, 2. Thank you. Yeah, full house is 3 cards of one type and 2 cards of another. So 3 kings and 2 aces.
Of the same card.
Of the same value of card, correct. So not the same suit, same value of card, right. It's also a horrible, horrible show from the 80s. Okay, this is even worse than this.
Different numbers?
There's a hidden surprise inside. So we need 3 cards of one type and 2 cards of another. So for any value, how many cards are there? 4. So if we need 3 cards of that type, you would say 4, 3. So this would say like 3 kings. And now we need 2 cards of a different type. So how many cards are there in any value? And we're picking 2 of them. So 2 aces. But I conveniently left this spot over here open. Because what else do we need to pick? Uh-huh. No, we got to pick something else. That's what makes this problem evil. We have to pick 2 values. How many values are there? And how many are we picking?
2.
So that's what makes this one so awful. Because we have to pick the values. And then within the first value, we're picking 3 out of the 4 cards. And within the second value, we're picking 2 out of the 4 cards. Yep. Why do the values matter? Because that's what defines a full house. 3 of one value, 2 of another value. I have no idea also what we get here. Anyone? 1,800. That's all?
Yeah, 2.5 million.
That's not a lot. That's with the 13 too? Oh.